Hi, and welcome to 1.1 Measurement Practice. Number 1, an official Major League Baseball has a mass of 145 grams. What is this mass in kilograms? And it says to use dimensional analysis and multiply by a conversion factor. Check your work using the acronym method. So we want to write our number down with its units, then just set up the dimensional analysis. Multiply by parentheses and put a line in the middle. Now we're going to convert out of grams, so we write grams on the opposite side. It's in the numerator right now. We'll put it in the denominator, and we want to change it into kilograms, it's asking in the problem. So how many of one thing is equal to the other? You look in your reference table, your good old physics reference table, in the front page, bottom left, you find the prefix for kilo, or K, and it's 10 to the third. So what do you do with that information? Well, this means that 1 kilogram is equal to 10 to the third grams. So there's your conversion factor right there. 1 kilogram is equal to 10 to the third grams. So the conversion factor again, 1 kilogram is equal to 10 to the third grams, just to put it more clearly. Then you just, since we already wrote where the units are, that tells us where to put the number. So the kilogram is on the top, that's where we put the 1, and the gram is on the bottom, that's where we put the 10 to the third. So there's no guesswork. That's why I like the dimensional analysis, because if you do the process correctly, then all you have to do is set up the numbers and you should be good to go. So you multiply the numerator, that's 145 grams. I'll write it out just for this one so you could see kind of like the math that's going on, times 1 kilogram, all right, divided by, this is over 1, and we have 1 times 10 to the third grams. That 1 doesn't have a unit. So you'll get 145 kilograms, which is a really weird unit, but that's okay because it's about to cancel out. And then you have 1 times 10 to the third grams. So the grams will cancel, leaving you with just kilograms. And then your math looks like this: 145 kilograms over 10 to the third. And then you could either plug that in your calculator, or if you know your powers of 10 rules, you could kind of do it in your head, and you'll get 0.145, 3 decimal places, kilograms, which makes sense. So then you want to think about it. 145 little things is equal to a small amount of big things. A kilogram is big compared to a gram. And you could even do the acronym method by going, here's the decimal point, and if you look at the table, you have to go 1, 2, 3 to the left to do that. Mr. Nagel, that was a lot easier than this crazy math. I highly recommend you get used to doing it this way. This is totally unnecessary. I was just doing that just to show you the math that was kind of happening in the background and really try to lay it out there as plainly as possible so you could kind of see where the numbers are coming from. But you could just plug it in your calculator as soon as you get to this point. Just 145 times 1 divided by 10 to the third, or just 145 divided by 10 to the third. So let's try that like this. So a human hair is approximately 50 micrometers in diameter. What is that in meters? So you write the number down, multiply by parentheses. Where do you put the unit? It's in the numerator here, so I want it to cancel out. So I'll put it in the denominator here. And what am I converting into? I'm converting into meters. Now that I know where my units go, I just have to know how many of one thing equals the other. So I'll look in my table, and the prefix micro is right here. So we'll do 1 microgram. Oh no, what is it? A micrometer? Micrometer is equal to this many meters. That's how this table works. 1 micrometer is equal to that many meters. So 1 micrometer is equal to 10 to the negative 6 meters. And then you could cancel out. And then you could even just write, okay, that's 50 times 10 to the negative 6 meters. But that's not correct scientific notation. It should be 5.0 times 10 to the negative 5th meter. So number 3, so that's the answer there. Number 3, a hydrogen atom has a diameter of about 10 nanometers. Express this diameter in meters and then express it in millimeters. So we're writing 10 nanometers is, we're going to multiply by parentheses, put this. So we put the nanometers on the bottom just so that it cancels out. It's not always going to be like that, but for all of these it pretty much is. And we're converting into meters this time. So we need to look up what the nano is. And here we have 1 nanometer is equal to 10 to the negative 9 meters. So those are the numbers we'll plug in. 1 nanometer is equal to 10 to the negative 9 meters. And we'll do the multiplication. We'll cancel it out. And we get 1 times 10 to the negative 8 meters. Now we're going to express this diameter in millimeters. So we could go from nano into milli, but since we already have it in the base unit of a meter, let's do that. So you write down the number 1 times 10 to the negative 8 meters. Then you multiply by your parentheses. Okay, meters are in the numerator, so we'll put them in the denominator so they cancel out, and we want to go into millimeters. So what's the prefix for milli? 1 millimeter is equal to 10 to the negative 3 meters, a small amount of meters. So we'll write those numbers in. 1 millimeter is equal to 10 to the negative 3 meters. And there it was opposite, right? So before the prefix was on the bottom, now the prefix is on the top. Why? Because we started in the base unit and we wanted those to cancel out there. So we'll divide. So it turns into 10 to the negative 8. These cancel out. Divided by 10 to the negative 3. You plug that in your calculator. Make sure you're using parentheses or the E button. We'll talk about that capital E button in a future unit. But for now, just try to plug everything in with parentheses around them so you get the right thing when you're dividing by the power of 10. And you'll get 1 times 10 to the negative 5th millimeters. Okay, now it says the land speed record is 1,228 kilometers per hour. Convert this speed to meters per second using dimensional analysis. So here's how I write these when I'm converting. I write 1,228 kilometers per 1 hour, like that, because it's per hour. You could set it up like a fraction like that. Then you multiply by your parentheses and you put the line in the middle. We could convert everything at the same time. We'll just do kilometers first. So we want to go into meters. Okay, so kilometers into meters. The kilometers are on the top. We put them on the bottom. And we want to go into meters. So you look at your table again for kilo. And we know that 1 kilometer is equal to 10 to the 3rd meters, 1,000 meters. So again, the dimensional analysis helps us because by writing the units first, we know where to put the numbers. 1 kilometer is equal to 1,000 meters, or 10 to the 3rd. We could also, should I show it in one line here? So you could write equals and then get a number, and that'll tell you how many meters per hour, but we want to go into meters per second. So let me do the next one. And you could even go from hours directly into seconds, but I'll go from hours into minutes first. So from hours into minutes, the hour is now in the denominator. So this is our kind of our first one where it was like that. So if we wanted them to cancel, we'd have to write it on the opposite side, not hour meter, an hour. So these will now cancel. We want them to go into minutes. Okay, so how many of one thing equals the other? Well, there's 60 minutes in 1 hour. So we'll do it like that. And we'll cancel out hours. So far we have meters, but we don't want meters per minute. So again, you could have done, do you know how many seconds are in an hour? You could have done that in this step here instead of minutes in an hour. But I just wanted to be fancy and make it super long and complicated for no reason, I guess. So the minutes are on the bottom here, and then you could put the minutes on the top so that they cancel out. and we want to go into seconds. And you see how we'll get a meter per second. The second is in the right place now, okay? And again, how many seconds are in a minute? So there's 60 seconds in 1 minute. The minutes will cancel out and we'll be left with seconds. That's how this works, right? So we could do, I'll do it all out. So 1,228 times 10 to the third times 1 times 1. So we don't have to write that. And then we, on the bottom, we'll have 1 times 1 times 60 times 60. So 60 times 60, which is 3,600. So there's, if you wanted to write 3,600 seconds right here, and then you wouldn't have to write that part, you could totally do it that way. So 1 hour is equal to 3,600 seconds. And that kind of eliminates one step. But you don't have to do it that way. You could do it out the long way. And you should get about 341.1 repeating meters per second. And if you didn't get that, you probably didn't put this in parentheses. So make sure that when you're dividing, especially, you have your denominator in parentheses so that your calculator doesn't mistakenly do PEMDAS when you didn't want it to. So just to put that in perspective, that's pretty fast. When we're talking meters per second, think about how long, can you estimate how long 300 meters is? What about 300 yards? How about 100 yards? 100 yards is a football field, right? 300 yards is 3 football fields, and a meter stick is about the same size as a yardstick. So this goes over 3 football fields in how fast? How many seconds? 1 second. 3 football fields in 1 second. That's fast. That's crazy. All right. Now we got some estimation ones. So if you came here for the estimation problems, here we go. The approximate length of a pencil, and then they give you all these crazy numbers, right? So I like to put them into more manageable numbers that I could visualize if I had to estimate them, right? So 10 to the negative 2. Negative 2 is a centi, all right? So we can convert that. And in this situation, the thing I like to do is if I see times 10 to the negative 2, I just replace that with a c, with the prefix. So that's equal to 2 centimeters. And if you think about like a ruler, if you know how big a centimeter is a pencil 2 centimeters? Maybe if it's like sharpened all the way down, maybe, but this says unsharpened on purpose, right? So 2 centimeters is too small to be an unsharpened number 2 pencil. 10 to the negative 1 meters. If you wanted to, you could go, okay, 10 to the negative 1. I can make this look like 0.2 meters. That's what 10 to the negative 1 means. And then I want to convert that into 20 centimeters. You could think of it like that, 20 centimeters. And now think of a ruler. A ruler, like a foot-long ruler, is about 30 centimeters long. So 2/3 of that, 20 centimeters. That's pretty reasonable. Let's see if the next one's any better. So 10 to the 0 is 1. 2 times 1 is 2. Think of how long a meter stick is. Is it 2 meter sticks? No, meter stick, like a meter is about a yard. It's not 2 yards long. And then 10 to the 1 is 10. So this would be even longer, 20 meters. Definitely not either of those. So it's going to be choice B. Okay. The length of a football field is closest to what? So this is kind of going in the opposite direction. You can convert everything into, I would convert everything into meters because I know that a football field is 100 yards, which should be around 100 meters. So we're looking for an answer that's about 100 meters. So let's see, centi is 2 decimal places, 1, 2, 10 meters. That's how you do that with the, if we wanted to do the acronym method. Decimeter is 1 decimal place, so that's 100 meters. Kilometer, you have to go the other way. So 1 and then 3 zeros after that. So 1,000 kilometers is equal to 1 million meters. And then it goes the other direction again, 1,000 millimeters. Milli is 10 to the negative 3, 1, 2, 3. So this is equal to 1 meter long. So which is closest to a football field? 1,000 decimeters. The mass of a paper clip is about, it's close to like 1 gram. So definitely not. This is equal to 1 million kilograms. That's very massive. This is equal to 1,000 kilograms. It's too bad that we're not in the classroom because I typically like pass around one of those kilogram masses. Think of maybe like hold like 2 apples in your hand. That's like what a kilogram is. Maybe a little bit more massive than that. And then 1 gram is about a paperclip. So 1 times 10 to the negative 3 kilograms. That's 0.123 grams. I'm just doing it the acronym way. I know you guys like the acronym way. Oh no, that kilogram. So I just moved it. I took it out of scientific notation and left the prefix. Now we can move it like this. This is equal to 1 gram. So that's looking pretty good, 1 gram. And then we have a number that's even smaller than that. So it's definitely not going to be less than a gram. So that's why it's choice C. And number 8, the mass of a football player. I said in the presentation, your textbook typically says 70 kilograms is the typical mass for a student. So somewhere in this ballpark is what we're looking for. So 10 to the 0 power is 1 kilogram. That's really small compared to 70. 10 to the first power is equal to 10 kilograms. So again, pretty small compared to 70. This is 100 kilograms. 100 kilograms is closer to 70 than 10 kilograms is. And if you're talking about a football player, maybe they're like a big football player as compared to a typical student. Or is it 1,000 kilograms? Like more than 10 times as massive as a typical student? I don't think so. So it's going to be choice C. All right, and that's it for 1.1 measurement. Have a great day.